Academy. This video will cover the topic, Basic Properties of Logarithms. There are three properties of logarithms that we will be focusing on today: the product rule, the quotient rule, and the power rule, and they are listed over here in the top right-hand corner. The base of each log, a, is a positive real number, not equal to 1. M and n are positive real numbers, and p is a real number. The reason it's important to have basic logarithmic properties is so we can condense or expand logarithmic functions into a solvable or simpler form. I will provide 3 examples focusing on a specific logarithmic property. Let's begin with an example problem that focuses on the product rule. So let's begin. We have log base 7, 3, plus log base 7, 4. Now if we look over at our chart in the right hand corner, we see that a is going to be substituted with 7, m is going to be substituted with 3, and n is going to be substituted with 4. So now we see that an equivalent logarithmic expression is going to have the same base a when we're applying the product rule. And in this case, our a is 7. Now in order to get the equivalent expression, we need to multiply m times n, and we've said that m is 3 and n is 4, so 3 times 4 is going to give us our equivalent logarithm. So this log is mathematically equivalent to log base 7, 3 plus log base 7, 4. Now let's do a problem focusing on the quotient rule. Okay, we have log base 4, 7 minus log base 4, 3. In this case, our a is going to be equal to 4. Our m is going to be equal to 7, and our n is going to be equal to 3. So now we see that an equivalent logarithmic expression is going to be log base a m over n. We have a, which is equal to 4, m, which is equal to 7, and n, which is equal to 3. So, putting the pieces together, we end up with log base 4, 7 over 3.
Oh, I understand. So when we have two logarithms with the same base being added together, then their components will be multiplied together. And if we have two logarithms with the same base being subtracted, then their components are going to be divided.
Yeah, exactly. Now let's do an example involving the power rule. So in this case, our base a is going to be equal to 3. And our m is going to be equal to 2, while our p, a real number, is going to be equal to 4. P is an exponent, 3 is a base. So with the power property, it says we can take the exponent on the component m and put it outside of the logarithm. So we end up with 4 log base 3, 2. Here are the 3 examples we did in this video. To the right, you can see their equivalent logarithmic expression.
Okay, this is starting to make sense. So does this mean that if we wanted to expand the logarithmic expression, we could just work backwards?
Yeah, exactly. For example, log base 4, 7 over 3 equals log base 4, 7 minus log base 4, 3.
Okay, so when we are adding together two separate logarithmic expressions with the same base, then their main components are going to be multiplied together. Now if those separate logarithmic expressions have the same base but are being subtracted, then their components will be divided respectively. If the component of a logarithm has an exponent, then it can be taken out and multiplied by the logarithm.